Even in teaching, AI is must. When you're talking about the SDG goals, each and every teacher should undergo the AI course, at least minimum one course, at least for preparation of PPT or slide. Without AI, we cannot teach nowadays. It's very difficult. The young teachers, they should learn AI. And what is the main use of AI? Actually, AI is playing a major role in various domains, especially image recognition, language translations. You can convert in any language. I think most of the times when PM is speaking in Hindi or in English, it can be converted into any Indian languages. I think that is developed by our own AI city New Delhi. And similarly, e-commerce, automatic car without driver, we can use the car using your AI. How AI is playing a role in biomedical? Actually, in biomedical engineering, what do you want? You want detect the disease and cure the disease. How the instrumentations will be useful in this? The state of art equipments or instruments should detect your disease in time, and based on this, we have to give the medicines. Actually, artificial intelligence can be applied using machine language, deep learning models through algorithms. It's a software, you know that, to analyze, detect, classify, and forecast the process of various diseases of human body. Definitely, the AI is detect the disease in time, or otherwise you can say early detection, and accurate detection is must, especially for cancer. So this FDP program definitely give the overall idea about instrumentation, biomedical instrumentation using AI. It will be more useful for young
సతీష్
researchers,
ప్రసాద్ సార్
those who want to do research in biomedical
சார்
engineering
இந்த இப்போ
using
ரெக்கார்ட்
AI.
லைவ் போயிட்டு இருக்கு
Definitely,
பட்
this
ஆனால் ஸ்க்ரீன்
FDP
மட்டும்
program will be useful.
பிளாக்காக
So
இருக்கு
I
சார் என்ன
request all the
பண்ணலாம் சார்
participants from various colleges try
சவுண்ட்
to attend
வருது லைவ்ல சவுண்ட்
all the
வருது
sessions daily,
பட் ஆனால் ஸ்க்ரீன் பிளாக்
and you
ஆகுது
can
ஸோ
interact the
சோர்ஸில்
speakers
அங்கே போயிட்டு
whenever you
ஏதாச்சும் ஆட்
want.
ஆன்
If you
பண்ணி
have
எதாவது
any
பண்ணலாம்
doubts, at the end of the session you can ask questions,
ஆமாம் சார்
or even after this
கிளிக்
program
பண்ணால் அப்ளிகேஷன்
get their
ப்ரௌசர்
emails
பட்டன்
or WhatsApp
விண்டோ
number,
கேப்சர்
and you can contact those persons for your future research.
ஓகே சார் அதை கொடுத்தா
With these few words, once again I thank the organizer, Professor ND Bobby and her team, to
எஸ்
invite me
காமிக்குது
to
ஓகே
to deliver the presidential address in
ஓகே
this occasion.
காமிக்குது
Thank you very much. I wish the FTP
தேங்க்யூ
program
சார்
all success. Thank you.
ஸ்ட்ரீம் ஆகிட்டு இருக்கு சார் தேங்க்யூ சார்
Thank you very much, sir. I now invite M. Srivira, founder cum managing director of Approx Tech Private Limited, Coimbatore. She is a dynamic biomedical engineer with unique ideas to make new innovations in biomedical devices to bring out a betterment in patients' healthcare and also a business person. And an innovator who has experience both in technical and in commercial fields. Srivira completed Diploma in Mechanical Engineering and B.Tech Biomedical Engineering at MIT Manipal University and worked as a research data analyst in IMPRO project of Unicorn Medics Limited, UK. Initially, Srivira worked as a cable TV operator and revamped the business, which led to an increase in the business revenue by 55% in before her BME studies. She has got various certifications for the courses of usable security, sleep, neurobiology, medicine, and society facial expression recognition with Kira's diabetes, the essential facts. She is also a winner of an IT hackathon and an awardee of the Entrepreneurial Contribution during COVID-19 times. Srivira has relevant skills of Python, machine learning, and artificial intelligence, and an overall business experience of 7 years and has research experience of 6 years. She also offers internship and training for biomedical engineering students regarding biomedical research studies under the Trailblaze Academy. Ma'am, now I request you to deliver the inaugural address.
Yes, good evening, one and all. Thank you for the warm welcome. A special thanks to Dr. Bobby, Professor and Head Department of Biomedical Engineering, and I also extend my thanks to Dr. P. Dhananjayan, Vice Chancellor, and also to Mr. Ganesh sir for giving me an opportunity to deliver the inaugural address in this event. So, recent trends in biomedical applications using AI. So, I hope all are familiar with these terms and this topic. Anyways, these were briefed by Dr. Bobby ma'am and also Dr. Dhananjayan sir previously. So I don't want to elaborate more on that. But just I want to give you a glimpse of how the biomedical engineering applications are being used and how we use it in our startup ecosystem since I'm in the entrepreneurial field for nearly 3 to 4 years. So nowadays, the opportunities in the biomedical field are huge, and scope of exploration is even higher. But at the time when I initiated my studies in the biomedical field at the year of 2016, the colleges offering biomedical courses were very rare. And at present, due to the dynamic changes in the startup ecosystem and related developments, the scope of biomedical studies started developing across all areas, specifically in stem cell engineering, tissue engineering, and also AI. So, when talking about the AI, recent news stuck in my mind. So, a girl from Kerala, aged 11, develops AI app to detect eye diseases with nearly 70% accuracy. She's just a school student, and her name is Leena Rafiq, and the AI app is named as Ogler Eye Scan. So this shows the collaboration of biomedical engineering with AI, which also indicates the effective use of AI in healthcare management system. So this girl is capable of achieving in the healthcare management system at the very early times with her knowledge. And at her stage, we, the biomedical engineers, are also responsible for developing a sustainable environment in healthcare and medtech sector, especially in the startup ecosystem, which needs to be looked off along with the trends of AI. So regarding our startup, what we do practically is I run a startup in the medtech sector since 2020. So that's when we got our company incorporated. It's Aprox Tech Private Limited. And our startup focuses basically on developing solutions to various healthcare problems and offering products that are non-invasive nature. So as all a biomedical background, you guys are already familiar with the non-invasive term. So non-invasive nature products or our focus. So we focus on non-invasive method of diagnosis for major chronic diseases. So our aim is to develop product ideas and launch them in the market to make the people aware about the benefit of early diagnosis rather than getting lately diagnosed. And so explaining about our product is practically what first we do is we make innovations and we bring up an idea that is a proof of concept is getting ready after a deep research studies is done for months. Then we get into the product development, that is the prototype development, that is a working model of our product idea. Then we launch it into the product market after getting relevant clearances, ethical clearances and certifications and all. So this is what our basic protocol of the startup ideas, which we are carrying out since 3 years. So basically now we have 2 to 3 products currently. So the first project idea is a non-invasive bands. So that is the first thing, and the second thing is pachycardiography. So this is entirely related to the non-invasive diagnosis. The first is related to therapy, that is just a non-invasive FAR therapy band, and the second pachycardiography is related to diagnosis. That is nothing but so we can diagnose the risk of heart attack if we are at a risk of heart attack or not through non-invasive method. That is when through use of urine sample we can just come to know we are at a risk of heart attack or not. So this is our primary product which we are working on, and that is going on a full swing. And we also plan for other products also in the same method, that is using urine sample. We also plan to diagnose all the major chronic diseases of heart, including kidney, liver diseases, and even cancer. So in the biomedical field, while exploring the biomedical applications, we came to know a lot in the research studies that diagnose everything using urine sample to the far extent as we do in blood. So using blood samples only, we basically we all take tests and we all coming to a conclusion that we are having diseases so and we are going to treatment further. But at that time, we are in the very advanced stage of the treatment, especially in the stage of cancer or heart attack. Suddenly, only some person getting heart attack and they are just being dead. But our aim is to protect such death and protect such adverse health conditions, and by diagnosing in a very, very early diagnosis. Just we are trying to bring all the applications in a single kit that will be like a regular health checkup kit. So this is what we are working all about. So this is entirely possible only with our deep biomedical research studies and also through the use of AI in all our applications we develop. That is in all our products. So this is what we do in our startup ecosystem. So you biomedical students are for capable of developing more creative ideas and also developing more products and launch in the market. So just study in your college time and just apply in your practical life. So that will be more beneficial not only to your family but also far to the society, for betterment of the society also. Many people are suffering due to the diagnosing the diseases at very late stage. So this is what our motto. So you guys will be having many clear ideas and many ideas in the mind. So please don't just stop with ideating it in the mind itself. Just screen it off and just develop it as an idea, write it off in a paper and just work it out and work it out practically. Definitely your product will be in the market in some day. So that at that time you will get a mental satisfaction that your studies and your application of knowledge has led to the betterment of some people, at least for one or two. So that is what my initiative, and that is what I try to propose. That you should also just go in such a way and take your studies in that career path. So never stop dreaming, start innovating and implementing your creative ideas for the betterment of the people. So good luck, guys, for all of you. Thank you.
Thank you, ma'am, for sharing your valuable insights. I now invite Dr. Ian Ganesan, Director, Research and Development, St. Peter's Institute of Higher Education and Research. He is an eminent researcher and educationalist with 30 years of experience and in teaching and research. He worked as a principal and vice chancellor. He has 15 Indian patents with two innovations in the field of nanoelectronics and biomedical engineering. Best PhD thesis and gold medal in PhD. 20 years of administrative experience, 6 crores of 14 Indian government projects executed from DSC, Ministry of Environment and Forest, DARC, Ministry of Renewable Energy for the past 20 years. 20 consultancy projects worth 64 lakhs with various national and international industries. He has guided 14 PhD research scholars from Anna University and Vistas, 450 journal publications with H index of 52 API and Scopus, 52 national international conference publications with 14 Best Paper Awards, 51 national and international awards. India, Indian industries and agencies, 9 international books published, editor and reviewer for 15 international journals, more than 100 industrial courses and training from CII and software companies, 32 national, 10 international lectures during conferences and conclaves, participated in 2 Guinness records, one in CPR and Bharadam 2017. Also, experience as member in Research Advisory Board, PhD thesis evaluation committee, chief examiner, interview panel member, permanent internal review committee member of for DRDO and ISRO. Acted as chairman for NAT and NBA committee. Has achievement of 3 Guinness record in the medical field in CTR at section 2014 to 15. Sir, I request you to felicitate the program.
Thank you. Thank you very much. Are you able to hear? Are you able
Yes,
to
sir.
hear now? Okay, fine. I'll just take a couple of minutes. Important thing is in this artificial intelligence, which was there for the past 72 years, it was there in from 90s. It has come to many US universities, but it was there from 1954 onwards, I think probably 52 onwards. First, understand what is meant by artificial intelligence, where the machines learn to perform the task. This task, rather than simply carrying out computation, they are input by the human users actually. But the difference between the artificial intelligence and machine learning is the approach to artificial intelligence. Hello, are you able to hear?
Yes, sir,
Hello.
you are audible.
Okay. Machine learning is approach to AI in which a computer algorithm is developed to analyze it and make predictions. That is the difference between AI and ML. And these predictions being made from a data that is fed to the system. Actually, it's a medical database. And if you see what is the difference between the AI and the deep learning, deep learning is a form of a machine learning that uses many layers of computation to form a neural network. Okay, so neural network, a machine learning approach modeled after the brain in which the algorithm process signals via the interconnected nodes. We call these interconnected nodes being filled by the artificial neurons. So the presence of this neural network within an algorithm and making the layer of computation, okay, to describe it as a deep neural network. It is capable of learning from large amount of complex and unstructured data. You make it as a particularly classified data and structured data. And this is a basic definition. Everybody knows very well. With respect to this, how this AI there in the biomedical, I'll just spell out what are the things happening nowadays, recently for the last 2 months. Why the AI is beneficial for the biomedical imaging? Because it deals with the large data sets. So you can use this algorithm, improving the accuracy and medical diagnosis, enhance actually in radiology, drug discovery, and surgery optimization, saving time and resources. So this is the main reason why the artificial intelligence being used particularly for the biomedical imaging or the biomedical applications. There are 3 ways in which both the artificial intelligence and machine learning are transforming nowadays in air, particularly the top 3 giants in South India, Apollo, okay, and even the company GE has used this successfully both the AI and ML algorithms, particularly for the healthcare, due to better diagnosis because we're able to reach the rural areas. In both the will give the solutions to what will be the prescription main diagnosis and the treatment can be improved. Patient outcome is far better if I use the AI technology. Not only that, the administration of both the doctor and the hospital is performing very well for the past 1.5 years due to this AI technology. So, what are the technology actually in AI? It is there. Many of them doesn't know. And there are 4 important things. One is the natural language processing, knowledge graphs, the vision image processing, and predictive technology, prediction in future. These 4 is there now. There are another 12 technologies are there in artificial intelligence. We use this AI-enabled biomedical knowledge graph is the need of the hour. It is available in very big hospitals nowadays. And what can we do all these things with? Definitely, there is a much improvement in the drug delivery, drug management, drug competition in the market. And we can tell it as a precision medicine and best medical surveillance is possible nowadays with the artificial intelligence. And not only that, there are some challenges also. The safety of the patient, safety of the medical data, and healthcare overheads, and how the data being integrated. All these challenges are some solutions needed, which can be given to the students now to do plenty of projects. And finally, the last point which I want to share with you is This research topic, particularly the advances in the medical, developing both the AI or ML based solutions, it is much far better for bioinformatics rather than the biomedical application, because much things happening in bioinformatics only the people who are in that area come to know. I'll just spell out this one: prediction of the 3D structure of all the unstructured pattern in bioinformatics, prediction of important gene expression, identification of transposable elements, drug discovery, prediction of the interaction between the biological important proteins, druggable proteins, and ligands, prediction of autism, and a lot of COVID research is going on with respect to artificial intelligence. This makes the treatments far better in biomedicine, and therefore the risk factor can be minimized in all the diseases in future. That is the advantage of artificial intelligence. You please contact me. I have plenty of materials, patents, and applications, copyright, and transfer of devices in particularly biomedical. I am looking this opportunity to discuss with you. This is a very good opportunity given to me by the biomedical. I am sure by Wednesday for 1 hour I have beautiful slides for you, which I will discuss along with you. Thank you very much.
Thank you very much, sir. Now I request Dr. Muthulakshmi M, Assistant Professor, Amrita School of Engineering, Amrita Vishwa Vidyapeetham, Chennai, to take over the session.
Ma'am, am I visible, ma'am? Ma'am, am I audible?
Yes, madam.
Okay. Is my screen visible, ma'am? And are the slides changing?
Yes, ma'am. We can see the slides.
Yes, ma'am.
Yeah, I'm here.
Yes. Okay, yeah. So, a very good evening to one and all present. And first of all, my big thanks to Dr. Bobby ma'am, Dr. Chandrasen sir, and Dr. Ganesh sir for giving me an opportunity to share the knowledge with such a huge crowd who is interested in biomedical domain. As you all know, so the FTP topic is recent trends in biomedical applications using AI. So I'll be touching upon what are the different biomedical areas in the aspects of signals and images, and how deep learning is pitching in each of these process, and how it can enhance the diagnosis or the prognosis based on the signal and image based analysis. So, and then we'll be seeing as a case study how the respiratory diseases or the abnormalities are analyzed with the help of deep learning. So, once I say medical images, there are different modalities over which we can work upon, right? From our head to toe, all the body parts can be imaged for different type of diseases, and we do diagnosis based on images. So we do have an echocardiography where we are taking using sound waves to get the image of the heart. We have X-ray where X-rays are taken in different parts of the body. As an example, we have shown here the chest X-ray. Recently, we have been taking this chest X-ray a lot of times for the COVID people to understand how much is the pleural effusion. We have computer tomography, CT images. We have CT brain, different CT, and this is especially the CT of the heart, where we can see the blocks in the blood vessels which supply the blood to the heart. We have MR imaging, magnetic resonance imaging. This is as well the MR image of the heart, where we can see the ventricles, right ventricle and the left ventricle, and the muscles around it. And here is the blood portion. Here we have the ultrasound image. So we all know the pregnant ladies, they do take ultrasound image. We do have different other regions where we take ultrasound, but this is like the most common, right? People, the pregnant ladies, they do take ultrasound images to make sure that the uh, baby is in proper stage of development. We have PET and SPECT images where the radioactive isotopes are being injected, and then we take the CT image in order to know where exactly the problem is based on the activation of these radioactive isotopes. We have the histopathology images where either the blood samples, blood smears, the swabs, or otherwise we have the um, urine samples, your stool samples, any microscopic images are a body region. Okay, we do take the histopathology images where we can see the minute other organisms, right? Parasites or any other growth of any other different cells. Okay, so all these images as a biomedical person we can work upon and help the clinician in doing a very good diagnosis. There are not only images, right? As a biomedical person, we do work upon different signals. We do have ECG, electrocardiogram. This is the one which everybody knows, right? Whenever you go to a hospital and if you feel something, even if you're going for any other problem, also they might take your ECG to make sure that your heart is functioning properly, right? So this is our electrocardiogram signal where we can understand the functioning of our heart. EEG, you would have seen many of the research which is happening in the both in biomedical side as well as in analyzing how the brain activity is happening. We have EEG, electroencephalogram, where the activity of the brain is being monitored using the signals. We have electromyography, where we have the muscle. We can identify how the muscles are working based on the EMG sensors. We can take those signals and we can work upon. The electrical activity of the heart is captured in electrocardiogram, whereas the way the heart sounds are produced, the heart sounds are being captured in phonocardiogram. So recently, this is also being used for much of the analysis. And as you can see in one of the talk, they saying that in order to identify the um, heart failure in an early stage, heart sounds are one of a very good biomarkers which are indicative of the abnormalities in the heart. Then we have the electrooculogram. Electrooculogram, the based on our eye movement. Okay, so based on eye movement, you can capture the eye movement by keeping the sensors on either side of both the eyes, right? And we can keep the electrooculogram. We get the signals and we can make use of it. Electrodermal activity, like in muscles, the way the skins are responding, the way our skin is responding. Okay, so we can have an electrodermal sensors and understand how the skin is responding in stress analysis. These days, you see many of the people are having a stress problem. So the stress for stress analysis and for different other activities, ectodermal activity is being monitored. So this was in a nutshell to elaborate what are the different biomedical images and signals upon which you can work on in order to do a predictive analysis. So being a biomedical person, so we should be knowing that all these images are coming based on different sources. We know how the x-rays are obtained, how we have the this is the visible light image, right? This is for the skin cancer. You can have infrared image. This is ultrasound image. We have radio waves. In the radio waves, we have magnetic resonance images. Gamma rays are being used in your PET and SPECT. as a biomedical person, before even you start the diagnosis, you should be aware of what is being imaged and what is being
Hello?
captured, because that is more
Ma'am?
important in order for you to arrive at a proper
மேம் கேக்குதா மேம்?
diagnosis. Okay, so from the moment we start the acquisition of an image or a signal
யாரு மேம்?
till the diagnosis, as a biomedical person, we
சரி
should
நீங்க
have
சொல்லுங்க
the
மேம், என்ன
end
பண்ண
to
சொன்னா
end
அதை பண்றேன்.
understanding of what is happening with respect to disease or with respect to a normal person. That's how the diagnosis will be in a positive side. Okay, so in a nutshell, we have seen how the medical images are captured and how the medical signals are captured. Now comes the most important part, right? The deep learning. You would have heard this word deep learning every time, right? This is deep learning, AA, or buzzwords. So till now, whenever you want to do a medical image analysis, okay, till now you would have done the image analysis. The entire cycle of image analysis will be happening in traditional way. But now each and every step deep learning has taken over, because our intention is to get a very good result, right? So this is the entire cycle, you can say, which happens in any of the medical image based diagnosis. You want to do an image enhancement, you can see this is an ultrasound image where you have the image enhancement, you have image segmentation. We can make use of, we have unet architectures, vnet architectures, omega net architecture is that, GAN, generative adversarial networks, right? So all these architectures take image as an input and provide image as an output, right? So you can train it for enhancement, you can train it for segmentation to get a particular mask, either ways. So whatever might be the requirement, either an enhancement or a segmentation, whenever you have an image input and an image output, we can make use of unet, vnet, omega net, combinations of these, ynet is there, right? And different versions of GAN, generative adversarial networks. Then, so the initial thing was, we have the image. In traditional, we used to take features, then use any of the machine learning algorithms, and then do the classification of the disease. Now, the people, what they are doing is, whatever the traditional way they were able to get the features, still the features lack some information regarding the underlying pathology. So, but because of the number of more layers, number of more filters, more kernels, the deep learning models are able to extract very good features. So before even you go to the classifying part of the deep learning, a layer before that, you can extract the deep learning features. They call it as deep features, right? So the deep features, you can use any of the network. I've just given some example networks, VGG16, LXNet, versions of Inception, different versions of ResNet, MobileNet, Efficient Nets. But we can make use of combos of this. You can make ensemble model with this. You can make voting with that. And you can take deep features and give it to any of the machine learning models. Okay, if you believe that the features in the underlying pathology are uh, very sparse, are very randomly distributed, which cannot be captured in normal way, then very well, there is lots of research which is going on this deep feature based analysis. And as a normal way, you can make use of any of the deep learning networks for directly classifying. Right, this is the lung CT. So based on the lung CT, you can classify what is the abnormality, whether it is a COPD or an asthma or a pneumonia. You can make use of it directly. You can classify with the entire architecture itself without taking deep features. Directly, we can use it to classify. Fine, I have classified. Can I identify something? Yes, you have an image, you want to identify which is the region of interest, you want to identify the abnormality. Yes, you can do that using any of the object detection algorithms. YOLO, different versions of YOLO starting from V1 to V8. You have RCNN, masked RCNN, fast RCNN, right? So any of these general object detection algorithms can be very well be used for detecting the object in our medical scenarios as well. Okay, so we have seen different deep learning architectures in medical image analysis. So how about signals? So as I told you, in nutshell, we are going to see how the medical images as well as the medical signals, right? Both can be analyzed for a diagnosis based on deep learning. When it comes to signals, right? So just like images, once you have the signals, signals do have artifacts, right? And signals noise will be there. So you want to remove the artifacts or you want to denoise the signal, you can make use of autoencoders, you can make use of any of the recurrent neural networks, upgradation of recurrent neural networks, LSTM, right? LSTM along with GAN you can make use of. Okay, so any of your signals, it might be ECG, it might be EEG, it might be your PCG, whatever might be your signals, in order to remove the artifacts or if you want to denoise it, we can make use of deep learning. It will give you a wonderful result. Fine, so I have taken the signal, I have removed the artifacts, I have denoised it. So the next is I want to identify some particular portion of the signal. Just like image segmentation, I want to localize some part of the signal. Okay, so what type of architectures can I look into? Same, I can make use of RNN, LSTM, GRU, gated recurrent unit, temporal CNNs. Recently, temporal CNNs have come, which is CNN along with the temporal features, right? So these architectures can be used for your sound segmentation. Basically, sound localization is nothing but segmenting a particular region of the sound signal, okay, and identifying it. Okay, so how about classification? Fine. So I'm doing all these things because from the sound signal I want to classify something. That is, I want to identify if there is an abnormality. Is that is I want to identify the different stage of the disease. Or I want to identify whether the person is diseased or not, whether the person is healthy, right? So I can make use of the, there are two ways. Either I give the sound signal to these architectures and then I can make use of the existing architectures. That is one way. Or other way is I take the sound signal, I get the features out of it. It can be MEL features, it can be wavelet features, right? And those features I can give it to the existing deep learning architectures, and then I can do the classification. That is also possible. Here you can see this MFCC is nothing but the MEL spectral coefficients. So which is a feature which is derived from the signal. Okay. And next is the predictive analysis. Okay, so this is what this, the fifth one is what now everybody is interested in, right? That is, you have a smartwatch with you, you want to know, okay, if today this is my BP, this is my heart rate, okay, so how it will be tomorrow, so that I can make a prediction. Okay, if I feel that, okay, so for past 2 days if my heart rate was low, okay, so then tomorrow this is how it will be, so I need to go to a physician, right? No, fine, okay, I'm going in a healthy state. So there needs to be some prediction. This is what we all are aiming at, right? Because we have huge amount of data with us, so we want some predictive analysis which can help us out, right? So once again, these RNN, LSTM, GRU architectures can help us in doing our predictions. Fine. So, as a whole, I was just talking about uh, in a broader way what are the different architectures. So, if you're going to do an image based deep learning based diagnosis of a disease, okay, so in that perspective, what are the different things you need to look into? That I'll be giving you an idea about it. You all know, in biomedical field, one of the biggest hindrances is less amount of data, right? Though there are public databases, there are certain diseases and there are certain scenarios where the number of data is less. So in that case, so the very first process will be augmentation of data, right? So we can do resizing, rescaling, rotation, flip. So first is we make sure that there is no class imbalance, right? And especially if you see normal data will be, if you take 100%, 70% will be normal data, 30% will be abnormal data. And if you give, even if it is a deep learning model, you give such a data set for analysis, what will happen is it will be biased one. Definitely, the 70% of uh, data will be in a higher point in tuning your deep learning model, right? So I need to have a class balance. So how do I do that? I can go for data augmentation. Fine. So now I have done a class balance. I have all the datas with me. Okay, for all the classes more or less in the same count. Okay, fine. So the data is available with me. So what is the next one I need to do? Obviously, we do take images. So definitely there will be resolution problems. So we need to do image enhancement. So how do I do it? So you've already seen, right? I can make use of auto encoders. You take any of the encoder decoder architecture, like all these UNet, VNet, LinkNet, all these are encoder decoder networks. You have the image, you have an encoder part, and then a decoder part. Once again, you get back the enhanced image. Okay, so that's how the training happens. And during the testing phase, you get an enhanced image based on the weights learned, right? That's how even your GAN works, generative adversarial networks work. Okay, and even transformer architectures. Okay, now lots of vision transformer architectures are being used in different applications. So even they are used in many of the research studies for image enhancement. Okay, so I have enhanced the image. So what is the next part? Though deep learning models are very good learners, you can give the entire image and let the uh, deep learning model learn and classify what is the abnormality. But what is the requirement of a physician? So the requirement of a physician is to identify where the abnormality is, to identify which region it is, right? So for that, I need to do image segmentation. So here you can see in this, there are different regions. Aorta is there, gallbladder, left kidney, right kidney, liver, pancreas. Okay, here they have used UNet model, UNet trans unit, right? So this has been, that is transformer along with UNet, has been used for segmentation. Uh, Deep learning models might be time consuming. It will take lots of time to, especially if you go for segmentation and image enhancement, you require high performance computing Yeah, with very good GPU processing. Okay, with that itself, it will take a 4 days or a week time for training and then for testing. But in many critical cases where the our traditional segmentation algorithms have failed, deep learning models are able to give a very good results. Okay. So we can make use of it. So image classification. So this is the CT scan of these are healthy people. In the bottom you can see the lung CT of healthy people. On the top you can see the people who are affected with COVID. So like this is an easy case where seeing the image itself we can understand that okay, the person is infected with COVID, but that is not the scenario in many of the uh, people, right? So here we can make use of deep learning architectures for automated classifications, right? See this as a person, now I am sitting, I am looking into it. For me it might take, let us assume that take 1 second. So how many patients I can do the diagnosis in a given amount of time, considering a country like India where we have such a huge population? If these diagnoses can be automated, it will be so useful, right? So we can make use of these deep learning models, which you can see on the left. These AlexNet, VGGNet, GoogleNet, ResNet, TenseNet, SqueezeNet, these are the initial models. Now we have MobileNet, ShuffleNet, EfficientNet. If you want to create this as an embedded device or as an app, you can make use of this MobileNet, ShuffleNet, EfficientNet. Okay, and Vision Transformer and Swing Transformer are recently used for the classifications, right? It will be so useful if you can design an app which can inbuilt, just you take the CT scan and give it to the app, and the app tells you okay, this is the stage of infection. How beautiful it will be. So here you can see. So here we have the colorectal cancer image. Here there are different cells. You can see these boxes are identification of the different cells. So they are basically they are counting how many HT29 cells are there, just to show that the object detection is also helpful in our biomedical side to identify the object, to identify the cells, to count them. Okay, so here they have basically used the YOLO architecture, and we have YOLO V1 now. Recently YOLO V8 is the recent version, right? So if YOLO you find it to be bulky, you have the architectures before it, SSD architecture, fast RCNN, faster RCNN, right? And the already existing, even the architectures which are used for classification can also be used for object detection. So that is also possible. And YOLO, it's working in a very good way. Even we have done the parasitic egg detection. That is, if you see the you have soil transmitted helminthes disease. Okay, so it is a fast transmitting disease. It is being analyzed based on the stool samples, and for any physician to identify what is the type of parasite, it takes some time. And if you have many people and it is a, it's kind of, if it gets transmitted, it will be in a easy way. So we did in YOLO, then we have converted that it into an app. If you just give the pathology image, it will find out what is the type of the parasite, and it will tell. Okay. So Are these the only areas where you can make use of deep learning? No, not at all. Still more. We can use deep learning even for image fusion. Okay, so any of the existing architectures, GAN, okay, you can use the normal fusion methods and then go ahead with deep learning, or after deep learning you can make use of normal fusion. Both are possible. So why do you do fusion? You feel that one modality gives me one information and another modality gives me another information. Why not I fuse both the modalities to give me a better information about the disease, right? So here they have actually MR and PET scan has been fused to understand what is the type of uh, impairment in the brain regions. Okay, so for image fusion also we can make use of the deep learning models. Fine. If you see the traditional machine learning architectures, the traditional machine learning architectures were explainable by themselves. That is, you know that if this is my diagnosis output, I can very well say that the input has this phenomenon which was responsible for providing this output. But our deep learning models are kind of a black box. We don't know actually what is happening inside it because they have so many layers within them, and there are so many filters, and they take so many features. So we don't know what exactly in the input is responsible for providing me this output, right? So for that they came up with XAI. This is now the most important research topic, explainable AI. So once you design the model, okay, so there are different explainable AI techniques. I've uh, shortlisted some of them: GradCam, SHAP, Lime. So after you create the deep learning model, you can give those models and the input to any of these AI frameworks, XAI frameworks. So they will help you in identifying, as you can see on the right hand side, which part of the image or which part of the signal was responsible for producing this diagnosis. Okay, because that is more important. See, I cannot say that I have this input, this is my output, and I don't know what is the relation. Then as a biomedical person, we cannot say that as an excuse, because we should be clearly in a position, we should be in a position to clearly say these phenomenons or these scenarios in the input are responsible for this diagnosis, right? Because I need to provide a treatment, I need to plan my therapeutic strategy based on the input scenario, right? Though this is my diagnosis, I need to know what went wrong, right? So that based on that I need to plan my therapy, I need to plan my treatment accordingly, and I need to understand at which stage it is, right? So XAA is the next ruling area of any of the deep learning based study. So as uh, Dr. Ganesh sir and Dr. Dhananjayan sir were talking about generative AI, right? So this is what is need of the hour, right? So we require AI which can generate information for us. Okay. Till a few years back, we just wanted to get some information from the data available. Now that is not the scenario. We want to create new data which can help us out and which can make our life easy, right? So in what way the generative AI is going to help us out in different areas? Okay, so as you can see here, The robo by itself, it is analyzing what is the abnormality in the brain image. Okay, so in medical imaging, especially in the radiology side, there are different need of generative AI. Okay, in getting okay different images. Okay, in image reconstruction, especially generative AI is playing a very crucial role. So a broad discussion of, since this is the very first session in the FDP talk, so I wanted to give you a broad perspective of what are the different um, domains in medical analysis which can be taken upon by a deep learning work. So now let us see what are the different um, ways the respiratory disease can be analyzed using the deep learning architecture. So I need not say, after COVID, there are so many respiratory diseases, and the study about respiratory diseases has got a recent hike because there are people, more number of people are suffering from respiratory diseases, and that too we don't know what exactly is the problem. So as you can see, especially in South Asia, if you see, we have a huge number of asthma and COPD people, male and female both. You can see that in our South Asia, Southeast Asia, asthma and COPD people are more. And that too, if you see the respiratory diseases, most of us diagnose the respiratory disease at a very, very late stage. And we all know that lungs are irreplaceable, right? So the more we do an early diagnosis, it is very good. The earlier the diagnosis, the better will be the treatment, the better will be the survival rate, right? So the early diagnosis is very, very crucial. Seeing that to this much number, if you are able to identify asthma and COPD in a very early stage, the treatment could be very good, and the recovery rate will be very good. So when it comes to lung sounds, see, when I have a lung abnormality, there are different modalities, right? As I saw, you can go for a lung CT, you can go for a chest X-ray and identify what is the abnormality. But when do we go for a lung CT or a chest X-ray? When we have severe respiratory problems, then we go to a physician and then they suggest taking any of the X-ray or a CT, and then we go for the diagnosis. But being in an era where we have lots of uh, wristbands, we do have access to lots of wearables. I think you have an upcoming session on wearables as well. Okay, so we can capture these lung sounds. We have our respiratory sounds. I'm not talking about the breath sounds, the respiratory sounds. Okay, so the respiratory sounds can be captured and we can do an analysis. So, how do we capture the respiratory sounds? We can capture the vesicular sound. So, the first one is we can capture the tracheal sound. You can see here in the throat. The throat, we can keep some sensor and we can capture the tracheal sound both during the inspiration as well as the expiration. These are actually very loud sounds. And on either side of the throat, you can have the bronchial sounds. You can get the bronchial sounds on either side of the shoulders, on the back side as well. You can get the bronchovesicular sound. and on the edges of the lungs and all over the lungs, you can keep the sensors and you can capture the vesicular sound. So either it is vesicular, bronchovesicular, bronchial, or tracheal. All these sounds can be captured both during the inspiration as well as during the expiration. Okay. This is the way the sounds are captured. Okay. Now, once I capture these sounds, what is my next step? Now, the normal sounds have certain characteristics. But if you are having a problem, okay, if you have a lung disease, okay, so for example, if you have a pneumonia, what will happen is your lung sounds will have, so these sounds are called as adventitious lung sounds, okay, so which are produced when you have some abnormality. Okay, so when you have pneumonia, you have the fluid formation in the lungs. So in this fluid, when the air is traveling, you have this crackle sound. And if the crackle sounds are very feeble sounds, thin sounds, we have the fine crackle sounds. And if the crackle sounds are very thick, they call it as coarse crackles. And we all know wheezing, right? So asthma people exhibit a wheezing sound. Okay, so where we have a fast high pitch lung sounds will be there. For COPD and bronchitis, that type of sound is called as ronchi. Okay, so if you see the ronchi, it is a low pitched sound. When you see a wheeze, it is a high pitched sound. You can see fast the people will be taking the breath. Okay, you have the low pitched ronchi sound. Then you have pleural friction rub. Now, what does this happen is when the pleural formation in our lungs is rubbing with the lung walls. Okay, so that will cause a, and when the air flows through it, okay, so that will cause a problem. So that is called as pleural friction rub. And by birth, due to genetic problems, if we have a problem in our trachea or in the bronchitis, okay, by birth, because of which the respiration is not proper, so that sound is called as trido. Okay, so these are the different categories of abnormal lung sounds. Okay, so to if you see the lung sound based analysis, till now what they are doing is, as you can see here, they take the raw lung sound signals. After we take the raw lung sound signals, we either pass it, see, once I capture the signals, definitely our line noise will be there, which is a 50 hertz noise will be there. And most of these adventitious lung sounds, they range in the frequency of 80 hertz to 2K. So as you can see the MFCC spectrum above, the maximum is 2K hertz is the record 2K hertz. And then once you get the filtered signal, most of the analysis, they take features. Either they take wavelet features or they take melphalectal features. They take spectrogram. They take other acoustic features. Now all these are stacked up. Now this will form a matrix. Okay, the spectrogram, though it is shown as a, for the visualization, the spectrogram has been shown as an image. The spectrogram also is a matrix. We do have a matrix of spectral coefficients, that is we have the time frequency coefficients, right? So spectrogram, MFCC, energy coefficients, all this together, they'll form a matrix. So this matrix can be given as an input to a any of the deep learning models, VGG16, AlexNet, GoogleNet, ResNet, MobileNet, EfficientNet. We can give it to any deep learning models. Okay. And then we can take each segment of it and do a prediction. For example, if I am having a 15-second sound, I can divide it into different segments of 1 second, or I can divide it into different segments of 3 seconds and identify in that particular duration if that sound is adventitious or not and what type of sound it is. And whether, or I can directly make a prediction of whether the sound is pertaining to COPD, or whether the sound is pertaining to asthma, or whether the sound is pertaining to pneumonia. That classification is also possible, or I can identify what type of sound it is in order to better understand what might be the problem, or what type of um, fluid is present in the lungs, or whether the problem is there in the lung nodules. Okay, so anything is possible. So basically, as a whole, if you want to do any of the lung disease diagnosis based on the respiratory signal, so this is the basic architecture you need to follow up. Okay, so features might differ. You can take any feature, you can take different wavelet features or any other signal based features for that matter. Any transform you can do. Domain get those features to the existing deep learning architectures. Okay, and you can go for the further diagnosis. Not only for diagnosis, even you can do a predictive analysis. Like if this is the respiratory sound now, how will it be tomorrow, or how will it be in another 4 hours, so that you can identify whether the stage will be worse or whether it is in moving in a um, improvement way. For example, if you're doing some treatment, okay, so whether the treatment is has resulted in an improvement, that is also possible. You can give this signal features to any of the predictive networks, LSTM, GRU, and you can do the further predictions. So what is required? The need of the hour is, from the bottom, we have seen how to acquire it, how to collect it, right? The features when, right? And we have given it to the AI model, we get the diagnosis. But that is not enough, right? I need to store that data. Or see, you would have seen the COVID scenario, right? Many of the time, the diagnosis needs to be happening in a remote way. So I give this diagnosis and the data to a expert. Okay, so how the data needs to be stored in the cloud, how the expert opinion is going to be reverted back. Okay, so this AI cycle is very much required, whatever might be the diagnosis scenario. Okay, so as a biomedical person, you not only need to know about the raw data, you also should have an understanding of how this raw data can be processed and be made available to give a predictive analysis. Okay, so that completes the AI cycle of a disease diagnosis. Okay, so this is just for a COVID diagnosis based on, this is actually based on cough. Okay, so they have basically taken the cough sound from the patient and they have analyzed it to understand how severe is the COVID situation. Okay, this is, you can do it for anything. You can take the ECG data, and as we had the ma'am saying, we can make use of the ECG data and make an analysis of how our heart is functioning each and every day, right? And if there is an abnormality, how the uh, treatment is helping out, that can also be monitored in an efficient way. So You can make use of MATLAB, you can make use of Python, right? Either for both for your image analysis as well as for your signal analysis. You can make use of these toolboxes if it is MATLAB, and if you're going to use a Python, you can make use of these libraries: NumPy, OpenCV, Scikit, SciPy, PyTorch, TensorFlow, Keras. They'll do. People, if you are working with MATLAB, MATLAB also do supports all the deep learning toolboxes. So this was the broad idea of different stages of a medical diagnosis where deep learning plays a role. Okay, so any questions regarding the presentation, or any questions in general regarding this domain, we can take up now.
Hello.
Yes.
Hello, ma'am.
Yes, sir.
Yeah, I have a question.
Yes.
Yeah, I just want to know, like, so many papers in medical image analysis are coming these days. Particularly, everything is now focusing on using this CNN architectures of different kinds. So, first thing is these classical filtering algorithms, segmentation analysis. All those things, do they still have any role to play at all, or they will not be any useful at all in the future? That is my first question. Second question is, if a researcher wants to step into this field and apply AI for solving these problems, is there any specific direction that the person has to take? Like, for example, should the person focus on learning the different models, or focus on different diseases?
Okay, so coming to your first question, since the classification models are doing pretty good, where the segmentation comes into picture is, once you have classified it, you want to exactly identify what is the region being affected, then the segmentation comes into picture. Previously it was like we segment the region, and from the region we take the features and we analyze it. So it is like segmentation was aiding the classification. Now the way the analysis is happening is, segmentation is no more aiding the classification. It is rather, we identify that there is a problem, and we want to know, we want to point out where exactly the problem is. So in those scenarios, segmentation is having a role to play, not in the initial architecture of segmentation to classification. You want to exactly identify where the problem is. For example, which lung nodule is being affected, or which part has a cancerous tissue. In those scenarios, see, as a whole we identify that there is an abnormality, but to provide for example, now we have robotic based surgeries, so you want to identify exactly where the surgery needs to be done. So in order to localize it, the segmentation is having a very big role to play. Hope I have answered your first question. And regarding the second question, um, me as a biomedical researcher, I always see disease first, not the model. It is like, see, you have a problem, just like a real time scenario. I go to a physician, I say them, these are the symptoms I have. So then the physician looks into the symptoms, diagnoses me that, okay, this is the problem I have. Then they come up with the medicine. The medicine is the model. So we cannot have the medicine and find out a proper disease which can be cured by the medicine. That's how I see. A model is nothing but like a medicine. So always it is better find out whoever might be a biomedical researcher. So the first idea is to find out what is the major problem around you, which has more significance. Then find out for that particular disease, for that particular abnormality, find out what type of model can help you out, because there are certain models. If you see the transfer learning models, VGG sections, some are very huge, and if we are in a idea of developing a wearable, we need not go for such a huge model. Sometimes the disease diagnosis might be happening even with smaller CNN models. We have done a stress-based analysis, stress analysis basically. For that, we just require 3 1D CNN layers. That is more than sufficient for us to do the diagnosis, which has given us a 92% accuracy. So it is always better to go with the problem, then find out which model will suit your problem statement. So that, in my opinion and my research path till now, this is what is my suggestion. Hope I have
Okay, ma'am.
clarified it.
Yes, yes, ma'am. Regarding that first question, I just wanted to know, like for artifact removal, denoising, then
Yes,
for all these tasks, does the classical image processing algorithm has any role to play?
classical algorithms do have some effect. It is like, for example, if I really know that, um, let me see. If my noise, I know that my noise is exactly 0 to 80 hertz. In that case, I can very well use just a filtering technique and remove the noise below 80 hertz. That is more than sufficient. As I told you, if there is a scenario where I cannot identify which exactly is my noise, there are real time scenarios when you take the actual signal, you do face uh, certain different background conditions. So there, deep learning has helped a lot.
Okay, ma'am. Thank you.
I think somebody else has also raised the hand.
പ്രാക്ടീസ് ചെയ്യാൻ അതല്ലേ പറഞ്ഞത്. കുറെ ടൈം പ്രാക്ടീസ് ചെയ്യും, 100 ടൈംസ് പ്രാക്ടീസ് ചെയ്തോ നീ? ഇല്ലല്ലോ.
Any
എനിക്ക്
other
ശരിയായെന്ന്
queries?
പറഞ്ഞല്ലോ.
Ma'am,
പ്രാക്ടീസ് ചെയ്താൽ
Yes.
നീ എന്നെ വായിച്ച് കളിക്കാൻ.
ma'am, you have told that we can fuse two images of different modality, right?
ഫസ്റ്റ് ടൈം
Yes,
തന്നെ
ma'am. Yes,
എന്നെ
ma'am.
ശരിയാവുന്ന
Is there any condition that the modality should be of, say, if it should be a CT and an MRI, or an MRI or an X-ray, like that?
Ma'am, that's not a constraint. We can fuse any modality, provided after fusing you should get some useful information about that region.
Okay.
See, for example, when I am taking a chest X-ray and you take a lung CT, okay, if you try to fuse it, then it will be very difficult, because the way the X-ray is taken, it gives you a different view, right? You have the coronal, sagittal, axial view. So X-ray has a coronal view, whereas if you take the CT, it will be like a axial. So in that case, though you do a fusion, you may not useful information. So the only constraint for image fusion is you should make sure that you have both the modalities are in the same view. Both the
Okay, ma'am.
modalities
Okay.
taken are in the same view, because otherwise, after fusion, also see, the main intention of fusion is you should be getting some useful information. Like for example, if CT is going to give me an information about a muscle or a fluid, the MR gives me another information, and a PET gives me another information. So that needs to enhance and complement each other. So the only constraint would be to make sure that the different modalities are taken in the same view, inferable.
Ma'am,
Yes, ma'am.
so mostly we have seen that the deep learning is applied for image analysis, and you have mentioned about the signal analysis as well.
Yes, ma'am.
So specifically for epilepsy detection for EEG, have you ever noticed about the deep learning methods?
Ma'am, there are lots of work for epilepsy, ma'am.
Yeah.
EEG
So,
based epilepsy works. Yes, ma'am. For recent days, feature based, it is like, as I told you, they have taken the features and then they have used and given it to 1D CNNs. They have created their own customized deep learning models and they have used it, ma'am. And if you see past 3-4 years, there are lots of works which is happening in deep learning, especially with EEG, ma'am, and
so
for epilepsy.
taking EEG and after normalizing, we will be giving to deep learning.
Yes, ma'am. In
Or-
that case, you need to design your own custom models, ma'am, because these VGG, MobileNet, all these are 2D networks, ma'am. When you have
Yeah,
the
yeah.
epilepsy signal, it is a 1D. So you
Yes.
need to create 1D CNN architectures, and based upon the time dependency, you need to have, as well as LSTM and GRU layers, you need to add in between, ma'am. We'll be
Okay.
having 1D CNNs to capture the features. And in order to capture the temporal information, we need to have additional LSTM GRU layers. And these days, even attention layers are being introduced in order to identify which part of the signal is having most significant impact on the diagnosis. So you can do a very good research on that, ma'am. And it will be your contribution also, since you need to anyway develop your customized model. There is no pre-trained model which is available. So you can create your own model.
Okay. So most of the works are using with Python.
Yes, ma'am. Ma'am, you can create in MATLAB as well, ma'am. MATLAB also supports 1D CNNs. You can you can just download deep learning MATLAB toolbox. You can have 1D CNN layers, both LSTM, GRU, everything is available, ma'am. It is kind of a plug and play, and it will generate the code for the model. Then you can make use of it after the normalization.
Oh, that is a recent.
Yes, ma'am. You need to make use of 22. 22 itself it is available, ma'am. 22B, 23AB deep learning toolbox is available, ma'am.
Oh, okay, okay. Thank you.
You can take MATLAB 22B. I have worked in 23AB also. It is available, ma'am. Deep learning toolbox is available.
Okay. Thank you.
Is there any questions or can we end the session? Ma'am, is it over, ma'am? Muthulakshmi, ma'am?
Yes, ma'am. Participants, you can reach out to my email ID. I do always appreciate knowledge sharing. So any queries, you can always reach out to me either in my LinkedIn or to my email ID. We can discuss regarding any of the biomedical research topic. I am always open for knowledge sharing. So please don't hesitate. Yes. Yes, yes, ma'am. Thank you, ma'am.
Thank you, ma'am, for your knowledgeable session. Now I request Dr. N.D. Bobby, Professor and Head, Department of Biomedical Engineering, St. Peter's Institute of Higher Education and Research, to propose the vote of thanks.
I extend my heartfelt thanks to management and chairman and managing trustee, and also I extend my heartfelt thanks for this faculty to organize this faculty development program in this way by our vice chancellor, and also my thanks to the registrar, and also I extend my heartfelt thanks to directors of SPIHER, deans of SPIHER, and the HODs of all departments and also to the all faculty members, your active engagement, your insightful contribution and dedication, and sitting with us in this evening times to have the great learning experience. My special thanks to all the esteemed speakers over here, and a special thanks to Muthulakshmi ma'am to share her knowledge, whatever she has gained, to all the participants over here. Thank you all for making this FDB an resounding success. So I once again thank each and every participants. Thank you all. And I'll be posting the attendance link in the WhatsApp group and all the PPTs, everything in the WhatsApp group. Thank you all once again. And we'll continue this journey for next 4 days in sharing our knowledge. Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Thank you,
all.
ma'am.
Thank you, Bobby ma'am.
Thank you, ma'am.
Thank you.